All right, we're now looking at 8.4, graphing f of x equals a times the quantity x minus h squared plus k. And this is called vertex form. So in the last one we did standard form, now we're in vertex form. Now I want to jump down to this line right here. Vertex form of a quadratic function is blah, that's what I just read out. When h is positive, the graph is shifted right h units. When h is negative, the graph is shifted left h units. And we want to make sure that we notice the negative in the formula. So let me read down here. A times x minus 5, that minus 5 tells it to go right 5. It's the opposite of what is listed. And the minus 1 on the end tells them to go down 1, just plain old down. And I didn't read that part here, but the k value shifts up or down. So from this we can get our vertex really easily. Our vertex, he's going to be hk. And then again, I want to point out the negative that's in the formula. So if it lists a negative 5, then h would be a positive 5. And if it listed a positive 3, then h would be a negative 3. But the k value on the end, that does exactly what it looks like. Right? If it's a positive 3, it's going to be a positive 3. It's going to be up 3. So that's the big idea of the lesson. Another idea that is put in here is even and odd functions. Now, all functions are going to either be even or odd, and there's also the option of being neither. So there's those three categories. All functions could be placed in the category of being even, odd, or neither. An even function is whenever it doesn't matter if you plug in the positive or the negative version, you get out the same thing. An example of this would be y equals x squared. It doesn't matter if you plug in a positive 5 or a negative 5 into x, you're going to get out a 25. Right? That would be an even function. Even functions are symmetric about the y-axis. So our parabolas, they all have a vertical axis of symmetry. Whenever their axis of symmetry is x equals 0, which is the y-axis, then that means that they're going to be even. An odd function is one that we haven't really dealt with as much. It's when f of negative x is negative f of x. In the graph of an odd function is symmetric about the origin. Probably the most common one that we could think of would be y equals x. If you think about the line here, he's going to be symmetric about the origin. The origin is the middle spot, meaning that you could take this, let me see if I can zoom into this. You could take this left branch, oops, I wanted that to be a different color, left branch here, and you could rotate it 180 degrees, and it would be symmetric with the right branch there. The words even and odd are used, so there's going to be some kind of similarities there, and I'm not going to tell you outright what they are. I'm going to let you guys find those out. But even and odd, whenever you're doing these problems, make sure you look for where's the even and where's the odd. Where do those words come into play in this? So let's look at example 15 here. It asks us, is the function even, odd, or neither? Well, the rule for even is that f of x has to equal f of negative x. And the rule for odd is that f of negative x has to equal negative f of x. So these are just our plain old rules, and now we can just plug in algebraically to see what happens. So f of x, right here. For that, I'm just going to copy down our function. We got 4x plus 3. For f of negative x, I'm going to plug in a negative x anywhere that there's a plain old x. So I'm going to have 4 times negative x plus 3. Right, and we're trying to see, are these two equivalent? Now I'm going to pretty up the right side. So on the left, I'm going to still have 4x plus 3. And I want to know, is that equal to negative 4x plus 3? And the answer is no. So it is not even. Not even. Now on the right side, we've already got f of negative x right there. So I'm just going to copy them down. Negative 4x plus 3. And then on the right side, I'm going to plug in negative parenthesis, and then I'm just going to copy down f of x. That's 4x plus 3. Now I'll distribute in my negative, and I get on the left, it's going to stay negative 4x plus 3. And then on the right side, it'll be negative 4x minus 3. Here we have a positive 3 and a negative 3. So again, it's not equal, so it is not odd. And because it's not even and it's not odd, it's neither. Neither even nor odd. Here's a hint for the exponent piece. We have an exponent degree 1 right there with the x. And right, thinking about where does the even and where does the odd come into play. All right, that's 15. Let's look at 16. Again, looking at the exponent there's an exponent of 2 there. That's kind of interesting. We want to see, is he even? That's going to be if f of negative x equals f of x. Oh, and you know what? Last time I wrote it backwards. I'm going to write it the other way too. F of x equals f of negative x. So I want to see, is it even or is it odd? The test for odd is if f of negative x equals negative f of x. So for the even section, first off, we just have plain old f of x. F of x I can just copy down, x squared plus 5. And I want to see, is that equal to f of negative x? So anywhere there was an x, I'm going to put some parentheses and a negative x inside. So I'm going to say negative x squared plus 5. So the left side can just stay the same. Now the right side, this negative x squared, that's the same thing as positive x squared plus 5. And right there we have an equivalent statement. So this is going to be an even function. So you might be thinking about the exponents, right? We got an exponent of 2 right there. And something that we can remember is if it is a constant term like this, we say that he's degree 0. So this is degree 0, and that's degree 2. This up here, we had degree 1, which I had written there, and then degree 0. Right, just kind of thinking about what's happening there, right? This first one was neither, and the second one was even. All right, let's scroll on to the next page. Now we're actually back to graphing like what we were doing earlier. And on this, we're supposed to list all of the special pieces of our parabola. I'm not going to list all that out because I think that we can do that by now. Oh, and the bell's ringing, so I'm going to end the video. All right, we're looking here at example 17, and like I said in the last video, well, in the previous part of the video, I'm not going to list out the axis of symmetry or the vertex, the maximum min, the domain, the range, or the y-intercept. I think you guys are good enough at doing that. Actually, you know what? I will list out the y-intercept. I for sure want to graph this guy, though. And whenever I graph these, oftentimes I look about the shifts. So this plus 4 tells them to go left 4 units, and the minus 3 tells them to go down 3. So now whenever I get to graphing, we have our parent function, and let me just look up what the last problem was, just to remind me. No, this is our first vertex graph. Okay. So our parent, let me just graph him in really quick. We're at 0, 0, up 1 over 1, the other direction, then we'll go 1, 2, 3, 4. There's our nice parent. We remember the number 1 and 4. Right, we've used that before. We're going to use that again today. So we go left 4 and down 3. So I go left 1, 2, 3, 1, 2, 3, 4, and then down 1, 2, 3. So our new vertex is right there. Our vertex is at -4, -3. Now we use the numbers 1 and 4. So we look at right in front, there's a 1 there, right? There's like an understood 1. So there's no stretching or shrinking. It just is the same as the parent. We can go up 1 over 1 in both directions, to right there, and then up 4 over 2. And that puts us right there and right there. Now we just draw in our curve. And there's our graph. So this one right here, this guy is f of x equals x squared. That's our parent. And then this other graph, that's our actual graph that we care about. So our vertex there is at -4, -3. You can grab that immediately from the graph. The minimum, maximum, domain, range, and all that stuff, that comes just as the previous problems were. Now we want to look at our y-intercept, and this is a little bit different. For a y-intercept, the x value is always 0, so it's 0, y, right? So y-intercepts would always look like 0, y. Now we don't always necessarily list it as a point. Sometimes we just say the y value, but we could list it as a point, and that helps me to remember that the x value is 0 there. So I'm going to plug in a 0 in x. So I'm going to say 0 plus 4 squared, and then minus 3. That gives me 16 minus 3, which is 13. So my y-intercept is 13. So there's a little bit of extra work that you have to do there, but I'd argue that this vertex form is a whole lot easier because you can get your vertex just so easy, and then you can use transformations, whereas you don't have to do the whole -b over 2a, right? That was for standard form, not for this one. Not for this one. All right, let's look at number 18. I'm going to start off and I'm just going to try to graph this function. I'll go ahead and list all the characteristics out as well. Our vertex is going to be at 3, 4. The x value is always the opposite of what's listed here. So right here we've got the -3, so our x value is a +3. And then our y value is always exactly as stated. So we have the +4 and the +4. I take my graph. I go ahead and draw my graph. 1, 2, 3, 1, 2, 3, 4. There's that. Now I could graph my parent, but I'm going to hope that we have that in our noggin. We could look back up here just to remind us that it's this middle graph right there. That's our parent. And then we'd look at the numbers 1 and 4. And here we multiply by -2 on both of those, because that's our a value right up there. There's our a value. So that gives us -2 and -8. So down 2 and then left and right 1 puts me right there and there. And then down 8, well, I was at +4, so I'm going to be at -1, 2, 3, 4, right there and right there. And there we go. There's my parabola. And then I want to go ahead and list out everything that we need. We have our vertex. Our symmetry line is going to be x equals 3. And I'm going to go ahead and just graph that in so we can kind of see what that's doing. That would be that line right there. My domain is going to be all reals. Our maximum or minimum, we want to think to ourselves, does this have a maximum or a minimum? And this one's going to have a maximum right there. It has a top. So our max value is y equals 4, right? That's our altitude, our tallest spot. I already listed my domain. Next up we have range. Range and the max or the min go kind of together. So our range, we have a max, so our y values are going to be below the max. The max is 4. And then lastly, we want the y-intercept. So like before, for the y-intercept, we think about that having a 0, y. So our x is 0 there. Our x, if I can draw that in nicely, x is 0. So y equals -2 times 0 minus 3 squared plus 4. -2 times -3 squared plus 4. So that's going to be -2 times -3 squared is 9 plus 4, -18 plus 4, and lastly we get -14. These all would really have little equal signs there. And y equals negative 14. So my y-intercept is 14. I don't know why I boxed that in. None of the rest is boxed in. But there we go. There's all of our characteristics there. Let's look at number 19. Write a quadratic function in vertex form whose graph has the given vertex and passes through the given point. That's supposed to say point there. Our vertex is at 1, 2. And let's first just write down vertex form here. Y equals a x minus h squared and then plus k. Our hk, let's see if I can erase there, hk, that's our vertex. So plugging in our vertex, we'd have y equals a times x minus 1 squared plus 2. All right, I just took that vertex and I just plugged them right in. Now they give us this other point here so that we can find our a value. So I'm going to plug this x and y into our function. I'll do that right here. So we're going to have 10 equals a times 3 minus 1 squared and then plus 2 on the end. 10 equals a times 2 squared plus 2. I'm going to subtract my 2. That gives me 8 equals. And then I'll go ahead and square that term there. That's going to be 4a. So 4a. Dividing by 4, I get 2 equals my a. Now I'm going to take this idea, or that answer there, and then back up here, right there. Those together, I'm just going to plug in my a. Y equals 2 times x minus 1 squared, and then plus 2. And that's that. Let's see if we have another problem. Nope, that's going to be it. Right there, whenever we're writing the equation, given the vertex and a point, you will always first plug in your vertex, and then after that, you'll use that random point to get your a value. All right, there we go.